Welcome to this tutorial. Today I am going to show you how to configure a CI/CD pipeline with Azure Data Factory, helping you automate deployment across different environments. I have splitted this video into several sessions to make it easier to follow. We will start by understanding the existing infrastructure. Then we will have a deep dive into the development Azure Data Factory environment. Next is the creation of production environment for the deployment process. In the CI/CD workflow section, I will discuss about the approaches described in the Azure documentation. Then we will build the classic release pipeline. Next is a demo. And in the final thoughts section, we will discuss about the production consideration or the best practices in configuring the Azure Devops pipeline for a Data Factory. Approach that we will be covering in this video is automated publishing using the NPM utility provided by the Microsoft. So let's dive in and get started. First, let's understand the current setup. We have both development and production environment under the same Azure subscription. The environments are separated by a resource group, one for dev and another one for prod. This shows how the ADF interacts with all the services. We use a single user managed identity to connect to various services like SQL Server, Key Vault, and the storage account. All these resources are in the dev resource group. The goal of this demo is to migrate all the ADF artifacts from the dev environment to the prod using an Azure DevOps pipeline. Next, let us examine the content of Dev Data Factory. Here we have three pipelines. This is a copy activity that reads a CSV file from one storage account and write it into as another CSV file in the different storage account. This pipeline reads the data from a SQL server and write it into a storage account, and the output file format here is a CSV. Similar to the previous pipeline, again this is also parameterized. Both these two pipeline uses same data set. Then we have a pipeline for wait activity. It's a dummy pipeline. Now let's look into the list of link service that are used for this pipeline. So this is the link service that is used to store the password related to the SQL server. Here the connection is authentication method that is used is user assigned managed identity. The user managed identity is saved as a credentials, and you can see it here. Next, we have the linked service that connects the SQL server. Here the linked service ls_akv is used to get the secrets from the key vault. This linked service is used to connect to ADLS Gen 2, and again the authentication mechanism used here is user managed identity, and this is the credential that is used to store the user managed identity. Now let me start creating the production data factory. Observe the naming convention used here and also the resource group used here. Now let's start creating the storage account for the production environment. I am creating a storage account under the production resource group. Here I am changing from dev to PRD. Let me review and create the storage account. So our storage account has been created. Now let us create this a key vault to store the password for our SQL server. Here I am changing the permission model to what access policy. Creating the key vault. Now let me create the secrets for storing the password. Observe this name will be referred in the linked service for key vault. Here I am creating the user assigned manage identity. This identity will be used by the data factory to connect to storage account and key vault. Here I am going to assign some roles to the user managed identity which I have created earlier. As we need to read and write the storage, I am going to provide the storage blob data contributor role to the user managed identity which we created some time back. The next step here is to give the managed identity permission to access these secret. To do this, I'll create a new access policy that grants get and list permission and then assign it to the managed identity. This will be used by the ADF linked service to connect to the key vault to get the password for the SQL server. Next, this is the storage account where the input CSV file is stored. Here I am going to add a data contributor role to the managed identity. This is crucial so that the data factory can read data from the storage account. Again, this will be used by the linked service to connect with the storage account. Let's now discuss the branching and the deployment strategy. The process begins with a feature branch where the development work is carried out. Once the development is completed, a pull request is raised to merge the changes into the collaboration branch, which in our case is mapped to main branch. Publish branch is where all the changes, including the automated generated template, get published. By default, Azure Data Factory generate an ADF_publish branch for this purpose. Now, moving on to the deployment strategies, Azure Data Factory offers both manual and the automated deployment option. For manual deployment, Data Factory UI allows you to export the entire Data Factory as an ARM template, which can then be manually uploaded to another instance of a data factory. On the other hand, automated deployment is streamlined through the ADF integration with the Azure pipelines. To tie it all together, let me walk you through the CI/CD workflow mentioned in the Microsoft official documentation. Here the user raise a pull request to merge the changes from the feature branch to the collaboration branch. Then he click on the publish button in the Data Factory UI. This will generate an ARM template and deploy the changes to the dev environment. Then there is a release pipeline that is configured with the publish branch that will automatically deploy the new changes into the higher environment. If you note here that The publish is an manual process. Microsoft has provided an NPM package that will automatically validate and generate the ARM template. Let's move on to the CI/CD flow using the automated publishing utility. Here the collaboration branch is configured with a build pipeline that has this NPM package. So in this build pipeline, when a PR is raised and it is successfully merged with the collaboration branch, this build pipeline will be triggered, and this build pipeline validates and generates the ARM template as an artifact. Now the release pipeline uses these newly generated artifacts and deploy it into the higher as well as on the lower environment. For automated publishing using the utility provided by Microsoft, the first step is to create a folder within your repository and save your package.json file there. File will be used to install the NPM package. I have already set up a build pipeline that generates the ARM template. Let's create a new one. Click on New Pipeline, choose Azure Repos, and then select the repository where you want to create the build pipeline. Next, pick the starter pipeline option. This will generate a basic pipeline with boilerplate code. In this starter pipeline, copy the YAML from this page. Here you need to specify the location of the package.json file. Then you have to change the resource group, the subscription ID, and the data factory name. Once you have made these updates, go ahead and save the pipeline. Each time this pipeline runs, it will generate an ARM template. To view it, select one of the completed build runs. Click on the published to access the generated pipeline, generated ARM template. So this is the ARM template that is generated. Next is to enable the classic release pipeline. By default, the classic release pipeline feature is disabled. To enable it, go to the project setting, find the option to toggle on the release pipeline feature and enable it. Now that we have enabled the release pipeline, let's walk through the process of creating a new release pipeline. To create a new release pipeline, click on New, select Empty Job, set the source type to build, and select the build pipeline that generated the ARM template. Now add the ARM template deployment task to this job. Choose resource group as the deployment scope. To deploy the ADF artifacts to your development environment, we need to create a connection. I have already set up connection IDs for both production and development environment. To create a new connection, click on Advanced Options, select Service Principal and choose the appropriate resource group. Once that's done, specify the resource group, the location of the ARM template, which is a .json file, and the parameters. Again, these parameters can be overwritten in a separate session in the pipeline. We will revisit these overrides when we configure the production deployment pipeline. Now let us review the existing release pipeline which I have developed for deploying the artifacts to dev as well as the production environment. The ARM template deployment has two key drawbacks. First one is the deleted pipelines from the feature branch are not automatically removed from the live environment. Second drawback is if you have an active trigger, it will be in the stop state after the deployment. Now coming to the release pipeline, we could see that there are 3 tasks associated with this each stage, and the first and the last task is to overcome the drawback related to the ARM template deployment task. The first and the last task are pre and post deployment scripts. The Microsoft has provided a documentation on configuring the pre and post deployment script. Specify the script location, copy the arguments for both pre and post deployment task from the documentation. For the production deployment stage, the process is similar to the development stage with a few changes. In the ARM template deployment task, select the production resource group and use the connection ID specific to the production. Some parameter will needs to be overridden, and we are using pipeline variables to store these values. We are overriding values such as data factory name, key vault URL, resource ID for credentials. Now I want to show you how to override certain properties using custom parameters. This is useful when you want to modify properties during resource manager deployment that are not parameterized by default. Now go to the data factory, click on the ARM template and select edit parameter configuration. For better clarity on the JSON structure, copy it into an online JSON viewer. You will see various sessions related to data factory such as linked service, credentials, datasets. For this demo, we are parameterizing the linked service and most importantly the credentials. There is a documentation from Microsoft that details how to create the custom parameter file and how to override each section. First, create a custom parameter file and place it in the repository. The name of the custom parameter file should be same as the one that is mentioned in the Microsoft documentation. In this demo, we are using the equal to sign to keep the current values as default. We will override only the necessary parameters through the release pipeline. You can verify which properties are being parameterized by looking at the parameter section of the ARM template file. One key point to note is that by default, the resource ID of the credentials is pointing to the development managed identity, and the key vault URL is also pointing to the development environment. In the override section, the value of this parameter will be replaced with those in the pipeline variable, allowing you to manage these credentials across different environments seamlessly. Production key vault URL is available under this pipeline variable, and also the production managed identity, user managed identity resource related information is again available under this pipeline variable. For this demo, I am working in the feature branch where I have made a small change by renaming a dummy pipeline. The dummy pipeline is a pipeline which has a wait activity. After saving these changes, I have raised the pull request to merge these changes into the main branch. Once the feature branch is merged into the main branch, it automatically triggers the build pipeline. As you can see, the build pipeline has successfully completed, which means ARM template has been generated and is ready for the deployment. Next, we move on to the release pipeline. Here we can see all the stages for the pipeline have completed successfully. Now let's verify the changes that have been applied in the live environment. I'll check the pipeline name in the live environment, and as expected, the name of the dummy pipeline has been updated. Now let's head over to the production data factory to confirm that all the artifacts related to this pipeline are available. We can see we have three pipelines, including the renamed dummy pipeline, and we can see 3 linked services, 3 datasets. Let's also verify the connection in the production environment. I am testing the connection between the storage account and the data factory. Here I am pasting the production storage account name. The dataset is able to successfully establish connection with the production storage account. Additionally, we can confirm that the credentials and the triggers are also promoted to the production environment. In this demo, I have shown the process of making changes in the feature branch and merging it with the main branch, then automatically triggering the build and the release pipeline, and deploying the artifacts to the live and the production environment. Before we wrap up this tutorial, let's discuss few points when working with production DevOps pipeline. In production environment, the pipeline often include code analysis like Fortify to ensure compliance with the client-specific standards. These tools can detect issues such as hard-coded credentials in the dataset or the linked services. Another important step is archiving the build using the tools like JFrog Artifactory. This ensures that every build is properly stored and versioned. Again, this depends upon the industry which you might be implementing the pipeline. For a financial institution, they would need an archival as a part of their internal policy. Next would be the deployment to higher environment like production is usually handled in a more controlled manner. Typically, organization implements approval gates that require necessary approvals before triggering the release stage for production. In many cases, the automated deployment are allowed only up to the lower environment like dev or the test, while the production release pipeline may require a manual trigger. Thanks for watching this tutorial, and if you found this helpful, be sure to like and consider subscribing to my channel.